There is one place in the solar system where every machine should die. Temperatures reach millions of degrees. Fortunately for Parker, that superheated atmosphere is also incredibly thin, which makes surviving it possible. Radiation can cripple spacecraft. Magnetic storms can unleash more energy than entire civilizations consume in years. For thousands of years, humanity treated this place as untouchable. Then, on Christmas Eve 2024, humanity went closer to the Sun than ever before. The spacecraft was moving at more than 430,000 miles per hour, faster than any object humanity has ever built. Then, it vanished. For 36 hours, nobody knew if it still existed. No telemetry, no status updates, no proof it had survived. Because humanity had just attempted something that once seemed far beyond the limits of engineering. We had sent a spacecraft deep into the Sun's outer atmosphere. What it discovered there may explain a mystery that has puzzled physicists for more than 80 years. But first, it had to survive a place where every machine should die. For most of human history, the Sun was something to admire from a distance. Scientists could observe it, measure it, and build increasingly sophisticated models to explain its behavior. Yet, despite centuries of observation, there was one place they could never reach: the corona. The Sun's vast outer atmosphere stretches millions of miles into space. It is here that solar storms are born. The solar wind begins its journey across the solar system, and events capable of affecting Earth first take shape. For a long time, that limitation seemed unavoidable. The Sun's visible surface reaches temperatures of roughly 10,000 degrees Fahrenheit, making the idea of entering its atmosphere appear impossible. But understanding the corona was about more than satisfying scientific curiosity. Powerful solar eruptions can interfere with satellites, disrupt GPS navigation, interrupt communications, and in extreme cases threaten parts of the electrical infrastructure that modern civilization depends upon. And hidden within that corona was a mystery that had puzzled scientists for more than a century. A mystery that, according to everything we thought we understood about heat, should never have existed. According to basic physics, temperature should decrease as you move away from a heat source. Step away from a fire and you become colder. Move farther from a furnace and the same thing happens. The Sun does the opposite. Its visible surface is roughly 10,000 degrees Fahrenheit, yet the corona above it reaches temperatures of more than 1 million degrees, and in some regions, nearly 3 million. For decades, scientists struggled to explain how an atmosphere could become vastly hotter than the object beneath it. The problem became known as the coronal heating mystery, one of the longest-running unsolved questions in astrophysics. Eventually, researchers came to a troubling conclusion. No telescope, no matter how advanced, would solve it. The only way to understand the corona was to enter it. That decision led to the launch of Parker Solar Probe in 2018. The mission was not designed to observe the Sun from a safe distance. It was built to fly directly into an environment no spacecraft had ever entered before. Then, in 2021, Parker crossed the Alfvén critical surface, a boundary where the solar wind remains physically connected to the Sun itself. For the first time in human history, a spacecraft was flying inside the atmosphere of a star. Justin Casper, one of the mission's lead scientists, later summarized the achievement in a sentence that captured the moment perfectly. "We have touched the Sun." But touching the Sun did not solve the mystery. If anything, it made the mystery even stranger. When Parker entered the corona, scientists expected answers. Instead, they found surprises. The first involved the solar wind itself. For more than 60 years, researchers had studied this constant stream of charged particles after it had already left the Sun. Parker changed that by allowing scientists to observe the process at its source, revealing how solar material accelerates and organizes itself before spreading across the solar system. It was like finding the source of a river after spending decades studying it hundreds of miles downstream. Then came an even stranger discovery. Instead of flowing smoothly outward, parts of the sun's magnetic field appeared to fold back on themselves repeatedly. Scientists named these structures switchbacks, and some stretched for millions of miles while carrying enormous amounts of energy. The discovery immediately raised new questions. Were these magnetic reversals helping accelerate the solar wind? Were they transferring energy into the corona itself? Could they be connected to the heating mystery that had puzzled scientists for generations? No one knew. And then, Parker flew through something most spacecraft are designed to avoid entirely: solar storms. Known as coronal mass ejections, these eruptions can hurl billions of tons of plasma into space. While scientists had observed them for decades, Parker became the first spacecraft to study them from the inside. What it recorded challenged another assumption. Not all of the material was escaping into space. Some appeared to loop back toward the sun, guided by magnetic fields that twisted and reconnected in ways researchers had never directly observed before. Not everyone agrees on exactly what the data means. Some scientists argue that switchbacks alone cannot explain the heating mystery, while others believe several different processes are working together. But one conclusion is becoming increasingly difficult to avoid. The sun is far more complex than we imagined, and for the first time, humanity is no longer forced to guess. We are measuring it from the inside. Long before Parker's solar probe entered the sun, there was a scientist who believed humanity would one day do exactly that. His name was Eugene Parker. In 1958, Parker proposed a radical idea. He argued that the sun constantly emits a stream of charged particles flowing throughout the solar system. Today, we call it the solar wind. At the time, many scientists thought the idea was wrong. One reviewer even recommended that his paper should never be published. But Parker refused to back down. Years later, observations proved he was right. Decades after that, NASA did something it had never done before. It named a spacecraft after a living scientist. When Parker's solar probe launched in 2018, Eugene Parker was 91 years old. He stood and watched a mission begin that many people once believed was impossible. He passed away in 2022, but he lived long enough to see humanity start the journey he had imagined for most of his life. Then came Christmas Eve, 2024. As Parker approached its closest pass to the sun, communication disappeared. For 36 hours, the spacecraft was completely alone. No commands, no corrections, no way to ask for help. Mission control could only wait. Then, on December 26th, a signal arrived, a simple beacon tone. Parker had survived, and for the first time in history, a spacecraft carrying Eugene Parker's name had returned from inside the atmosphere of a star. But the mission is far from over. Some of the biggest questions remain unanswered. What actually heats the corona? Are magnetic switchbacks the missing piece of the puzzle, or are scientists still missing something fundamental? And there is another question, perhaps the most important one. Can Parker help us predict solar storms before they reach Earth? An extreme geomagnetic storm could disrupt satellites, navigation systems, radio communications, and, in severe cases, create major problems for electrical infrastructure on Earth. Right now, warning times are limited, hours in some cases. Parker was built to change that. Every pass through the corona gives scientists a better chance of understanding how these storms form before they race toward Earth. History suggests that scientific revolutions often begin with contradictions. The observations that refuse to fit the model are usually the ones that change everything. and every pass through the corona is producing more of those observations. The sun is not what we thought it was. For thousands of years, it existed as a distant light in the sky, a symbol, a mystery, and something forever beyond human reach. Today, that is no longer true. A machine built by human hands has flown through its atmosphere and returned with discoveries that are already changing our understanding of how stars work. But the story of Parker Solar Probe is not really about touching the sun. It is about understanding the star that makes every moment of life on Earth possible. Because the same sun that warms our planet, powers our climate, and sustains life can also produce forces capable of disrupting the civilization we have built around it. That is what makes this mission extraordinary. Humanity did not enter the sun simply to satisfy curiosity. We went there because understanding our star may one day help us protect ourselves from it. For the first time in history, we are no longer studying the sun from a distance. We are learning its secrets from within.